So this is on systems of equations, and we're going to be looking at systems of linear and quadratic equations. So when we have a system of equations, we can solve them in two different ways. First way I want to show you is solving them algebraically. So what you would need to do is substitute in one of the values. So like this one says y equals, so we could take out the y and plug in what it equals. And that would look like this. X plus x squared minus 2x minus 3 equals 3. Now when we get it like this, we have a quadratic. We want to put everything on one side. And we're going to put it in order. So my x squared goes first. And then I do have two x terms. Alright? And I'm going to move over this 3. And I'm going to get a minus 6. Okay? So algebraically, this is what we have. This is a quadratic, so we would factor it. So we're going to split our first term. Decide our signs, which are plus minus. What would give us 6 when we multiply and 1 when we subtract? That would be 2 and 3. And I need a negative 1, so my big number has to be negative. Now remember, when we solved quadratics, we set each factor equal to 0 and then solved for x. So this is what my solutions would be. Okay? So algebraically, x could be 2, negative 2, and x could be 3. Now we want to find out what the y is when x is negative 2. So we're going to plug in a negative 2 for x in this short equation, and we're going to solve it. So y would be, if I move the 2 over, that would be 5. And then if x was 3, then move the 3 over, y would be 0. So my solutions are negative 2, 5. That's one of my solutions. And my other solution is 3, 0. Okay? So algebraically, we can substitute in an expression for one of the variables, solve for x or y, and then find the other value. Okay, so we're going to try it again. And notice these two equations say y equals both of them. So I could take this y out and plug that in. So that would look like x squared minus 4 equals negative 3. Okay, well, since I only have one x term, I'm going to move the 4 over. It gives me x squared is 1. Because I have an x squared term and I needed to find x, I will take the square root of both sides. Now remember, when you take the square root of both sides to solve, it's plus minus a 1. Okay? So my x values are positive 1 and negative 1. No matter what, my y value is going to be negative 3. Now we're going to try it just in case. We're going to stick a negative 1 in for x. Negative 1 squared is 1. And 1 minus 4 is negative 3. I still got negative 3. So my solutions are negative 1, negative 3, and 1, negative 3. Those are the solutions to this system. Okay? Let's try one more with solving algebraically. Again, these both equal y, so I'm going to take out this y and I'm going to put that in its place. And it equals negative x plus 1. So I want to move these two things to the other side, just so I get everything on one side. Let's see what we have. Up, x minus x makes that go away. Negative 2 minus 1, negative 3. So I can move that 3 back over. And again, I'm going to take the square root of both sides. Now this didn't, well, work with us very well because it gave us a radical expression. So if I plug in a radical for my x, then I'm going to get a decimal value as well, okay? So this particular equation would probably be easier if we graphed it. So let's look at graphing, okay? We're going to take this solution and we're going to graph it. So in Desmos, you're going to type in x squared plus x minus 2, x squared minus x plus 2. I think that's what I said. We'll make sure. X squared plus x minus 2. Put the plus and the minus in the wrong place. Plus x minus 2. Alright, and then we're going to put in that linear equation we had too, negative x plus 1. So negative x plus 1. So this is what our graph looks like. So let's see where our solutions are. I must have done something wrong when I plugged it in. So I have x squared plus x minus 2, x squared plus x minus 2. And then I have negative x plus 1. Negative x plus 1. Well, this says that my solutions are negative 3, 4, and 1, 0. So mathematically, I made an error because these two graphs do intersect at these 2 points. Those are the solutions. So if we are graphing a system of equations, no matter what type of equation they are, then the solution is where they intersect, okay? So I'll go back to that one and check it and make sure I did everything right. So let's look at this example. It says solve it by graphing. You have 2 systems, and this is what your graph looks like. So our solution is where those 2 graphs intersect. Our solution would be negative 3, 4, negative 4, and then 1, 4. Okay? So let's try this one in the graph. X squared plus 3x plus 1. X squared plus 3x plus 1. And then our other equation, x plus 1. Alright, they intersect at 2 places as well. So our solutions are negative 2, negative 1, and 0, 1. So, not very difficult to find the solution, right? So let's see what this application of this type of equation looks like, alright? So the first one I want you to look at is the graph that I have here on the screen, and it shows a quadratic and a linear function, okay? So if you look at this graph, how many solutions do you see? It has 1 solution because it crosses or it touches right there at 1, 1. If the linear function, that's this straight line, were changed to plus 5, let's say we moved it up 5, 1, so we moved it up to 5, 1, 2, 3, 4, 5, it'd be right here. We moved it up here. How many solutions would we have now? We would have 2 solutions, right? Okay, what if we moved it down 2? So if we moved it to minus 2, it would be down here. Would we have any solutions then? No, because it wouldn't touch at all. So, what does it mean if there is no solution when you substitute one expression, or y, in the other expression and solve? Means we do not touch, does not intersect. There's no value for x or y that will be solved for. Okay? Alright. So here is an application problem. It says bathing suit sales at a clothing store can be modeled by the function, and it gives you an equation. And gift card sales can be modeled by this linear equation. X represents the number of months past January, and Y represents the total revenue in thousands. Solve a system of equations algebraically to find the month when the revenue from bathing suit sales is equal to the revenue from gift card sales. Now remember, the revenue was the y's. That means these y's have to equal. And algebraically, if we were going to do that, we would set them equal to each other. Okay? So to do that, we just move everything over. So minus 5x and minus 7. We get negative x squared plus 7x. And then that's going to give us 18. So we would factor. And I'm just going to change the sign everywhere so that we can factor it easier. So x plus and x minus. And 2 times 9 would give us our 18. Okay, and I do need a negative 7. So my 2 would have to be positive, my 9 would have to be negative. Alright, and if I take each of these and solve them, setting them equal to 0, I get 9 and negative 2. Now, if we are talking about number of months, would it be negative? No, it would not, so that one's out. 9 months past January. So 9 months past January would be our 10th month, and that would make it October. So in October, their sales are congruent. They're equal. All right? Now, we could graph that and find that. All right, let's look at another one and we'll graph it. All right, so it says here we have the height. Somebody's jumped tall cliff, and we have this equation. So we're going to put this in. Negative 4.9 x squared, negative 4.9 x to the square, plus 420. Oh, that spread out a lot, didn't it? All right, our other equation is negative 3x plus 200. All right, that one's going to be spread out too. Negative 3x plus 200. Okay, so my graph's going to have to come in a little bit so that I can see it. And so I'm looking for, where do they cross each other? Are we getting close? Yeah. So let's look. We have an intersection point right there. And we have an intersection point right there. So let's see what the question is. To the nearest whole number, how long after jumping does the flyer deploy the windsuit? How long after he has deployed or jumped does he deploy the windsuit? Now, our x is our time. We would not have negative time. So we're going to look at this positive time of 7 minutes or seconds. 7 seconds. Okay? Then to the nearest whole number, what is the flyer's height? Okay, so we're going to look at the y value to look at the height to the whole number. That would be 179, because that would round up in feet. Okay? So when you're talking height or time, it's not negative. Time is not negative, so we would look at the positive time. Okay? So solving the systems, we are going to graph them, and there's a few that we're going to solve algebraically. Okay?